Okay, welcome. Thanks for joining the webinar. Let me talk about the schedule or the plan for today. As always, I'll answer any questions, and that's throughout the whole webinar, but at the beginning too. And then we'll do a little review of discrete and continuous variables. So it got mentioned in week one, and now we're really going to spend time on it. We'll look at probability distribution tables, and that'll be very important, especially when we deal with expected value. So after probability distribution tables, we'll look at the expected value and the standard deviation. And then we're going to look at a special distribution, and basically it's about the yes/no question. And that is the binomial distribution. And see where that comes from, and then look at example questions that involve the binomial distribution. And then we'll look at continuous distributions. So those are important. They come up a lot. And I wouldn't say the most important, but the easiest one to work with is called the uniform distribution. And that one is going to be the one you can actually do the calculations pretty much by hand. And whereas the most important one, which is the normal distribution, that one you just got to trust the calculator and that's it. But the idea of the uniform distribution is you can get the idea of how probabilities for continuous distributions work. So we'll also look at the mean and the standard deviation of a uniform distribution. And that's important also. So there'll be some formulas for that. And that is pretty much the plan. Just a note, I have graded pretty much the discussion post assignment and the exams. Pay attention to my comments. That's important because, again, it's really important that you write correctly. And when I grade the exam, I mean, I grade the last two. The rest are computer graded. But at least the last two of them I grade myself. And I want to give you a heads up for those who are here and those who are watching recorded. Pay attention. There will be times when I say you must use this wording for your answers. And I take off lots of points if you don't use the wording I tell you to use. And for a couple reasons. One is the wording is important because it gives you a nice way of discussing whatever we're talking about. And the other is it helps prevent the use of AI because AI will not use the wording I use because it's going to use some other wording. And I will take a lot of points off because I'll assume you're using AI if you don't use the wording that I tell you have to use. So make sure you take notes, write down the wording that you have to use, especially when it comes to the expected value, because that's going to have certain words that have to be in the answers. And when I grade it, whether it's the discussion post or whether it is the exam for week 4, then you have to use that wording. So that's just a note. So are there any questions about anything from the class? And that could be about the project, it could be about other things, but I'm always happy to answer questions. And again, questions? I don't hear a question. So any questions, and I'll be happy to answer them. I want to remind you, you should be, making good progress on your project. The hope is you have put in your project idea on the Project One discussion board so that I can take a look at it and let you know if it's going to work or not. And often I'll say you need to make a few adjustments. Make sure you make those adjustments. So one question, can there be more than 3 on a project? The answer is no. Because if there were 4 of you, you can split into 2 groups of 2. If there are 5 of you, you can be a group of 3 and a group of 2. So 3 is the maximum on the project, 2 is the minimum. And 3 is best. So hopefully that makes sense. Any other questions? If not, just want to remind you this is an odd week, which means there's no exam this week. So that means that hopefully you'll have time to really push your project forward because it's a lighter week in terms of no exam, at least. We do have 2 chapters, but the chapters, I think the 2 chapters combined are easier than chapter 3. So just a note. But some people might find them difficult, but most people find them easier than chapter 3. Okay, so let's go and talk about discrete and continuous variables. And they come up in a big way because chapter 4 is all about discrete variables. And chapter 5 is all about continuous variables. And either way, they're both about quantitative. And here is a reminder, the definition: a discrete variable is a quantitative variable whose set of outcomes can be displayed as a list. Okay, so you have to be able to basically write them in a table. Sometimes it can have ... but you have to be able to kind of list them out. Okay, whereas a quantitative variable that's not discrete is a continuous variable. Okay, a discrete variable or probability distribution table can be created. That's really important. So one thing, and funny thing is, I didn't learn this in America even, but I guess I don't know if I mentioned this, but I actually taught English is a foreign language when I was in Japan. And then I had to like understand like the difference in the way we do things, the way we say things and the way the Japanese say things. And that's when I realized that discrete variable has a specific way of talking about it, and that is how many. So if it's a question, if you can answer the question as how many of something, then that'll be a discrete variable. Whereas typically continuous variables are often as how much or how long, something like that. So kind of nice little grammar ways. And again, I didn't even realize until I taught English that I never thought about the difference because we just say it naturally. So we're going to be starting out talking about discrete variables. And I'm going to give you an example. And here's an example question. And that is, a salesperson gives out a $10 gift to every customer who test drives a car. Okay, typical thing that happens in business is that you want to get customers in. So if you give them a little gift, if you say, hey, anyone comes in, we're going to give you $10, then you might be more likely to get more customers because people come in just for that. Okay, let's suppose that 12% of all customers who test drive a car purchase the base model of the car, and that results in a $200 commission for the salesperson. And let's suppose 8% of all customers who test drive a car purchase the deluxe model of the car, resulting in a $300 commission for the salesperson. Okay, kind of typical businessy kind of thing is that, you know, it costs you money to bring the people in because that you're giving them $10. But a lot of them are going to be spending a lot of money and you're going to get a big commission and hopefully you'll make a profit because that's what you want. You want to make money for your job. So the idea is we want to look at the profit. Okay, so let's start out by looking at all the different things that can happen. So one thing is if the customer purchases the base model, what's your profit? What's the salesperson's profit? If the customer purchases the base model, looking for what is the profit? If you can tell me, put in the chat box what the profit you think is. Good, good. Yeah, it's 190 because if you get a $200 commission, but you had to spend $10 to give the gift, then 200 minus 10 is 190. So our choices are 190. Similarly, if the customer purchases the deluxe model, what is the profit? Good, good. So that's 290 because if you get a $300 commission and it costs you $10 to give them that little present, then you get a $290 profit. Is that the only thing that can happen? Are those the only two things that can happen? What do you think? Is there anything else that could happen besides the customer purchasing the base model and the customer purchasing the deluxe model? Yeah, most of the customers are going to test drive the car and they're going to take the $10 and say, I'm not buying anything. Okay, and that happens. That's very common in, for that kind of thing. So the profit in this case would be -10. Because again, if you take the revenue, which is 0, and subtract the cost, which is 10, 0 minus 10 is -10. Any questions on that idea? Okay, so those are the three things that can happen. Notice this is a discrete variable because we're able to list all of the possibilities without a problem. In this case, it's just 3 of them. Any questions on the idea so far? All right, so then we want to say, what about the probabilities that could happen? So if we look at the probabilities, well, the probability of purchasing the base model is not 12, by the way, be careful. It's 0.12. So don't forget, when you're given a percent of the people that do something, you have to turn that into a decimal by moving the decimal place over twice. 0.12. And 8% purchase the deluxe model, and that is 0.08. It's not 0.8, by the way, 0.08. So it's a common mistake people will make sometimes. Any questions so far? Okay, then if we want to find out what is the probability that somebody will not purchase anything who has test drive the car, then one of the big things from chapter 3 is the total of all the probabilities must add up to 1. So if we call X the probability of not buying, not purchasing, then we can say X plus 0.12 plus 0.08 equals 1. 0.12 plus 0.08 is 0.20. So X plus 0.20 equals 1. Subtract 0.20 and you get X equals 0.8. Any questions on any of these calculations? It's all basic math, but that doesn't make it easy. Any questions? Because I'm always happy to answer any questions you might have. Any questions? Okay, if there are any questions, what we want to do next is we want to use what we just did to create a table. And the table that we're going to create is called a probability distribution table. Okay, and a probability distribution table has its rows as X and P of X. Sometimes you use columns instead of rows and just say the first column is X and the second column is P of X. Usually you do whatever fits best on your paper, okay, or on the screen. So here, I'm just going to write down all the X's. We have 190. We have 290. And we have -10. Any questions on getting the X values for the probability distribution table? Okay, then we have to write down what P of X is. That's the probability of each of these things happening. The probability of a profit of 190 was 0.12, so I'm going to put in 0.112. The probability of a profit of 290 was 0.08. So under 290, 0.08. And finally, the probability of X being -10, we calculated as 0.8. Are there any questions at all on finding this probability distribution table? Any questions? Okay. So now we're going to get into something kind of the most important piece of the discrete variable, and that is the expected value. Because really what matters, if this is your job and you are the car salesperson, or let's say it might be your job, you're thinking about taking this as a job, then probably for most of you, the number one thing that you care about, how much money are you going to make? Doesn't that sound about right? There'll be some other things you care about, but how much money you make is a biggie. Okay. Now, you're not making the same amount of money for every person who comes, because we can see there's 3 different things that could happen. So it's not how much money you're going to make on any individual customer, but you want to think about, if you have this job for a while, maybe you spend, a month working this job with many, many, many customers, then how much money are you going to make per customer on average? Any questions on that idea? Okay. And that is called the expected value. And there's a template for the expected value. And you must use this template, by the way. I will take lots of points off if you don't use this template. And the template is, if many trials are done, then it is very likely that the average of the trials will be very close to the expected value. So I just want to note something. I said the words many, likely, average, and close to very loud. Why did I say those very loudly? Any guess? What's your thought? Why do you think I said them loudly? Because it's going to happen a lot in this class. What's your thoughts? Okay, they're not necessarily exclusive to discrete. Some are, but not all of them. They're important, but I do want to mention that if you do not put these exact words when I give you a written problem that says interpret the expected value, you're going to lose a lot of points. So if all you do is, use ChatGPT, you're going to lose lots of points, because ChatGPT will not use these words. Got it? So hopefully everyone in the whole class, in both classes, is watching this webinar and really paying attention. Those words have to be in the answer whenever you're asked about expected value. Got it? Even if you put something similar, that doesn't count, because that's one way I stop AI from answering questions. So those words have to be in it. Everyone okay with that? Okay, I'm not being mean. I'm just making sure. And again, if you're paying attention, there's no problem. So write those down. Okay, on a piece of paper, make sure you write this template. All right, so just to note, the expected value formula is the summation of X times P of X. That's not You don't need to know the formula. Any guess on why? It's going to happen like all the time in this class. In fact, if you use this formula, I'm going to be pretty harsh on grading. If you make a little mistake, I'm going to nail you. Instead, how do I want you to do this? Find the expected value. Any thoughts? I don't see you jumping in. I want you to use your calculator. Okay, and the calculator that I made. So we have this 190, 290, -10. If I go to the calculator, which calculator do you think should be used here? You can just put the number in or put the words. Yeah, number 6, expected value and standard deviation. Okay, nothing's tricky here. I tried to make it as obvious as possible when I built these calculators, and it's the order at which we do things in the class. So that's why it's one of the beginning ones. We're only in week 3. And notice it says X and P of X. And it says enter the outcome of the probability and the probability of that outcome occurring, and then hit calculate. Okay, leave the bottom rows that do not have any values blank. And then do not include commas in your entries. And that's really important for this calculator. If there was a number like 1,000,000, don't put 1,000,000, comma 000. Make sure you just put 1,000,000,000. Okay, so don't ever use commas for numbers. Okay, so again, if I look at my numbers, I have X is 190, X is 290, and X is -10. So I type in 190, 290, -10. And we have the probabilities were 0.12, 0.08, and 0.80. Any questions at all on inputting our table into this table? Any questions? Okay, then we scroll down and we hit calculate. And it gives the expected value and it gives a standard deviation. So the expected value is 38. Okay, and by the way, let's write this down. Standard deviation, I'll write to SD is equal to about, how about 98.47? Okay. And there's a reason. There's a reason why I use 2 decimals. Any guesses? The hint is you would never use 1 decimal for this kind of question. Any thoughts? Don't see y'all jumping in. Let me give you a hint. Any thoughts on why I use 2 decimals? Yeah, it's money. And the way we look at money is dollars and cents. No one does 1 decimal. You could either do just dollars if that's good enough for you, or you can do dollars and cents. Okay, because that would be the natural thing to do. Any questions on that idea? So the units of the expected value and the standard deviation, both for this example, are in dollars. So now we can interpret the expected value. So if many, so let me remind you, many was really important. Customers come to test drive a car, then it is very likely that the average profit that the salesperson will make per customer will be very close to $38. So what do you think? Is it a good job or not? Okay. I mean, it depends. I don't know if any of you have ever sold cars. How long do you think it takes to test drive a car with a customer? I'm not a car salesperson, so I don't know exactly. But if it takes a half an hour, then you're making $76 an hour. That's pretty good. If it takes 2 hours to test drive a car, then it's terrible money. Then it'd be $19 an hour. Do you see how that works? So you should always look at this and how does it refer to the real world? Any questions at all on interpreting the expected value? Okay, if there aren't any questions on that, let's look at the standard deviation. Remember, the standard deviation that we've had before is a measure of how much your data tends to vary. Okay, in this case, $98 is a lot. Okay, given the expected value is 38, $98 is a big variation from the expected value. So the standard deviation is high. That does not mean it's a bad job. What it means is that you're not usually going to be anywhere close to the $38 per customer for any particular customer. So you're going to have big changes from customer to customer. So there'll be times that you're actually losing money. So when you see a standard deviation that high, then we're going to recommend that that salesperson better have money in the bank. But if the salesperson needs to go to the grocery store and get food, but all of a sudden the salesperson didn't make any money that day, then that's bad. So it would give some suggestions. So knowing the standard deviation helps understand what kind of money earnings this is going to be. Any questions at all on this example? Any questions? Okay, let me give you one more example. We'll do this one a little faster because we only have so much time. So let's suppose that you're offered a life and dismemberment insurance policy that costs $1,000 per year. Okay. The policy pays the heirs $100,000 in the event of death. Okay, if you die, you don't get any money because you're dead. But your heirs would get money if you die. Okay, typical life insurance, right? Okay. And $50,000 in the event of dismemberment. I notice that I've learned from the past that some people don't know what that word means, dismemberment. Anyone know what that word means? It's not a math word, it's English. You know what the word dismemberment means? Don't see y'all jumping in. Yeah, it's like losing a body part, okay? Having your arm chopped off, okay? It sucks, but you're not dead. So it's different than being killed. So dismemberment means that, it's a disaster, but you're not dead. So you're probably gonna need some money. Okay, but now it goes to you instead of your heirs because now you're alive. Okay, figure I should tell you what this means. Okay, the actuaries are the people who like make a decision and decide like what percent chance will things happen. So the actuaries have determined that you have a 0.3% chance of dying this year. and a 0.5% chance of dismemberment this year. Okay. Find the expected value and standard deviation and interpret the expected value. Then explain why the standard deviation might indicate that it still might be a good idea to purchase insurance. So what we're going to do is same idea. We're going to write x and p of x. Okay. What's one value of x that could happen? Put in the chat box. What's a possible value of x? Okay, 0.3, that's not a value of x. Good try, but that's not a value of x. 0.3 is not a value of x. You have ideas? Okay. You're close when you said 100,000. Actually, I think you meant 100,000 and not a million. You wrote a million. But there is an issue, and it's not a million, it's not 100,000, because remember, you still got to pay 1,000. So it's going to be 99,000. So 99,000 will be, sorry, 99,000 will be one possible value of x. Another possibility of value of x would be if you have dismemberment, you got your leg chopped off, and that would be 50,000 minus 1,000, which is 49,000. And a third possibility would be, I know this sounds weird, is you lose negative 1,000. That's the best thing that can happen. Doesn't that sound weird? When you buy insurance like that, you don't want to end up making money. Okay, I hope you don't, because you don't want to die and you don't want to have your arm chopped off. Okay, so that's just a note, good to understand these things. Okay, then P of x, the probability of dying is 0.3% chance. So it's not 0.3 for what you write, it's 0. We got to move the decimal over 2 places, 0.003. And similarly, 0.5% chance is 0.005. If you add 0.003 and 0.005, you get 0.008. And if you subtract that from 1, you get 0.992. Any questions on that arithmetic? And you always are allowed to use a calculator. You don't have to do what I did, which is use my brain calculator. You can use a computer calculator, it's fine. But I wanted to save a little time. Any questions on the x and p of x? All right, so then we go here. And by the way, if you want to refresh, you want to make sure these numbers are gone, the easiest thing to do is hit the refresh button on the browser. And then it starts over. So again, the x values were 99,000, 49,000, and negative 1,000. The P of x values were 0.003, 0.005, and 0.992. And I just hit calculate. And my expected value is negative 450. Standard deviation is, I'm going to round in the nearest whole number, so nearest dollar, 6,496. Any questions on that? So what we can say is that so by the way, do you think this is a good deal? If the expected value is negative $450, is it a good deal? Right. First thing, of course it's going to be negative. Why is it going to be negative? It's real life. Why will the expected value always be negative for insurance? You don't dial a time, but more importantly, is the insurance company has to make money. They're not going to sell policies if they're losing money on the average. Does that make sense? So if you look at it in the thought of the insurance company, they would think, well, if they were able to sell the insurance to many, many customers, then on average, they would make a profit and the customers would lose, on average, $450 per policy. Any questions on that idea? Standard deviation is 6,496. That's a big number. So why might you buy insurance, by the way? I always like to bring, statistics into real life. Even though the expected value is negative, why still might you buy insurance? Why is it sometimes a good idea? And the hint is the standard deviation is really big. And when I say you, it's not necessarily you personally, but why might a person still want to buy insurance given these numbers? Yeah, in case you die, but more importantly, if you happen to have someone that is dependent upon your money, they're going to need some money after you die, or they're going to be in trouble after you die. Like if you have a small child. Does that make sense? And this high standard deviation says that it's pretty severe difference. It's a lot of money they get if you die. Okay? On the other hand, if you have no dependents, there's no reason to buy life insurance, this kind of insurance, especially life insurance. Any questions on this idea? Okay, let's move on to the next piece of this chapter. This chapter really has two parts. And the next is called the binomial distribution. So a binomial distribution comes from multiple independent trials of a yes-no question and measures the number of yes answers. Okay. So yes-no questions are very common. Okay. And yes-no questions could be something where there's two answers, but they're not necessarily the words yes and no. Okay. So for example, it might be, instead of a yes-no question, it might be, let's say, you might be interested in something like, just trying to come up with a good question where there's only two different things that could happen. So it might be if you, let's say you took the bus, and it might be something like, are you coming in with with the long-term bus voucher that's free, or are you coming in having to pay? There's two choices, but that's still a yes. You could turn that very easily into yes, no question. And you just turn that into, do you have a long-term bus voucher? Do you see that? So if you can turn it into yes, no, we'll count that as binomial. Any questions on this idea? We're going to spend a lot of time throughout the rest of the entire course on these yes, no questions. Okay, and what you're going to be interested in is how many yeses, how many nos, or what is the proportion of yes answers that occurred in a survey that you do, or in the population. So let me give you an example. So this is an example. By the way, this one you can quote me on. I did research. And that is that there have been 142 years in recorded history of global temperatures. So I looked this one up for the last 142 years, ending at 2023. This year we don't know yet because we're only, in April. But 142 years they have been recording global temperatures. In the next 20 years, if the weather is random, find the probability that at least 10 of them will be in the top 10 for the prior 142 years. Okay. So this is an example of binomial distribution because the question would be, is that year's global temperature in the top 10? And it either is in the top 10 or it isn't in the top 10. That's a yes, no question. Any questions on why that's binomial? Okay, so what I'm going to do is I'm going to write down what is n. N, do you remember what n corresponds to? We've had this before in first week classes. What does n mean in this class always? We're going to use the single letter by itself, n, for one reason. What does n mean? Yeah, n is a sample size. Okay, so in particular, what is the sample size for this example? What is the sample size? I'm looking for a number. Not a trick question. It's easy. What's the sample size? Okay, so 142 is not the sample size. That's the population size. The sample size is 20. Because we're looking at those 20 years, how many yes answers are you going to get? So n equals 20. The probability of a yes answer, well, to be in the top 10 out of 142 years should be 10 out of 142. Any questions on that? Okay, so I just want to let you know, we want the probability, since it says at least 10 of them, probability that x is greater than or equal to 10. Okay, any questions on that? So I'm going to go back to the calculator menu. And which calculator do you think we need to use here? Should be easy if you paid attention. Yeah, number 7, binomial probability, because this is a binomial probability question. And what it says, enter the lower bound for the number of successes, the upper bound for the number of successes, the number of trials, and the probability of success. Then hit calculate. Okay. We want the probability that x is greater than or equal to 10. What's the smallest number that is greater than or equal to 10? This is really easy. That's a hint. Yeah, 10. The smallest number that's greater than or equal to 10 is 10. So the low is 10. What's the highest number that can be in the top 10 in those prior 142 years? Maybe I'll even do this, 10. I don't see jumping in. The highest number, 20. All of them. Can't have 142. If you're only looking at 20 years, you can't have 142 of the 20 years be something, because there aren't that many. But you could have all 20 of them kind of, if they were in that 142, they'd be in the top 10. Do you see how that works? Number of trials, that was 20. And P is 10 over 142. Any questions on that? So now I go to my calculator. We have 10. We have 20 for the high. Trials was also 20. P, I'm going to go to scientific calculator because I need to write it as decimal. Can't use fractions, by the way. And that was 10 over 142. And I can just copy and paste this messy 0.070422, etc. Hit Control C, Control V, and there's my P. Any questions so far? And it calculated. What is this probability, by the way? 0. What does that mean? Okay, it means it's pretty much impossible to happen to as many decimal places as this calculator can handle, which is a lot of decimal places, by the way. So this probability is equal to 0. So I want to let you know, I've been teaching this class for a long time. I gave this 20 years ago. If you look at the last 20 years we've had more than 10 that were in the top 10 for those 142 years. Okay. What does that tell you? This is very important because this is what this class is all about. It's not all about just a calculation. If this probability is supposed to be pretty much 0 and it ends up happening, what does that tell you? Any thoughts? It tells you right here that this assumption that weather is random is wrong. Okay, this is basically tells you that there is no question at all that we're in climate change right now. Does that make sense? Because this shouldn't happen. So then you go and this is what really research is all about, is it is a collaboration between statisticians, people who understand statistics well, and scientists. So the statistics clearly shows that randomness is not going on, that something has happened. So then the scientists go and they say, what are the things that could have happened that could make it so that this occurred, even though if it was random, it should be no chance. And what the scientists showed is that if you have a lot of carbon dioxide in the atmosphere, that's going to cause temperature to rise. Okay, just to let you know that. That's the whole point of this course, is to be able to understand that, how that statistics collaborates with science so that you can come up with conclusions that you know are correct. Any questions on that? So this is one of the most important examples, I think, of using statistics. Okay. I'll just go through a quick one more example before I get into continuous distributions. Let's do this. Put it on the same page. Okay, so 24% of people worldwide feel lonely. Okay, actually, this morning I looked it up. Okay, I looked it up. I looked up, interesting things, and this is what they found. Okay, if 17 randomly selected people are surveyed, what's the probability? First, that between 5 and 10 of them feel lonely. So here the low will be 5, the high will be 10. The trials is 17 because we have 17 people are selected. And P is 0.24 because 24% is 0.24. And I can quickly go in and see 5, 10, 17. So 5 for the low. High is 10. Trials is 17. And P is 0.24. And they calculate. So it says there would be about a 39% chance that between 5 and 10 randomly selected people feel lonely. Any questions on that? Very important for the field of psychology. This is an example of a psychology thing. Okay, any questions on part A? Okay, so for part B, at least 6 of them feel lonely. So one thing is, it's very important to be able to look at words like at least and know what those words mean. The very smallest number that could be at least 6 is 6. At least means 6 or more. So again, it's really important to be able to interpret the words. So the low will be 6, the high will be 17, with the same trials and the same P. So now we're going to go 6 and 17 for the low and the high. And now I calculate, and it's about 20% chance. Any questions on that? Okay, let's look at the next example. Fewer than 5 of them feel lonely. Okay, again, a lot of people have trouble. Hopefully you all know that the smallest number that's fewer than 5 is 0. Can't have negative number of people. So 0 will be the low. And fewer than 5 with a discrete variable, 5 is not the low, because 5 is not fewer than 5. The smallest number, the largest number fewer than 5 is 4. Trials is still 17 and the P is 0.24. Any questions on this example? So 0 to 4. And that about 61% chance. Any questions on that? Okay, and then exactly 5. So if you want exactly 5, what's the lowest number that could be exactly 5? Should be really obvious. 5. What's the highest number that can be exactly 5? Also obvious. 5. So that's going to go low as 5, high as 5. Trials is still 17 and P is 0.24. And you got about an 18% chance that exactly 5 of those 17 people will feel lonely. Any questions at all on this example? Any questions? Okay. By the way, my source was Gallup Poll. That's who I looked at that, and they're the ones that said they did a survey of people in all over the world. So if you trust them, then trust all of this. Any questions on that? Okay, let's move on to continuous distributions. Okay, so this gets interesting. Who remembers the shape of this picture? What's the name for the shape of this picture here? Shape of the distribution of this picture. Again, this happened a couple weeks ago. What is the shape of this? Yeah, the shape of this distribution is normal because it's kind of bell-shaped, and that's normal. If you want the probability that the x value is between 1.8 and 2.75, the definition of probability for a continuous variable is the area under the probability distribution curve above the x-axis between those two values. Okay, if this were a normal curve, then I will tell you that if you have not taken a full year of calculus, you're not going to be able to do this by hand. And if you have, then you still probably can't. And if you can, you're going to be crying. So it turns out finding the area under a curve that just has a weird like bell shape or some other weird shape is pretty tough. Okay, I know how to do it. It turns out for a normal curve, we're going to have a special calculator that does it for us, that I created. But what area do you know how to find? You have to think back in your, elementary school or middle school time. What do you know how to find the area of? Certainly not area of a bell curve, piece of a bell curve. But what do you know how to find the area of? Or at least at one time learned? What was the easiest? Okay, shaded area, not in this case. Shaded area, you don't never, I'm sure you've never learned this unless you happen to have had at least a year of calculus. I'm looking for a shape. What shape do you know how to find the area of? There's really 3 of them, but one is the easiest. Not seeing you all jump in. All right, let me tell you. Ah, there you go. Good. Yeah, square or rectangle. Rectangle is what we're going to be looking at. So rectangle really is the easiest. So what we're going to do is we're going to spend some time on when you have a rectangle shape for the distribution, because that's the one we can actually do without using some fancy calculator. So let us talk about that. And when you have a rectangle shape, we call it a uniform distribution. So a uniform distribution from A to B is a distribution such that any 2 given intervals of length k that is contained in A and B has the same probability of occurring, and any interval outside AB has 0 probability. Okay? And the way to say it geometrically is the distribution curve for a uniform distribution is a rectangle. Any questions on that so far? All right. What we write is we'll write x Who knows how to read this little guy right here? Who knows how to read that? It's on most keyboards, by the way, have that symbol. Who knows how to say that symbol? You've all seen it because it's on almost every keyboard, usually kind of top left next to the one with the shift. Anyone know? Okay, and you've also seen it and maybe used it if you learn Spanish. When do you need it for Spanish? Accent actually has a little this, it turns out. For Spanish, it's tilde. Yeah, tilde. And in Spanish, it's used for the ñ. And again, you don't have to know Spanish in this class, but if you happen to, it's you've seen it in the ñ, which is one of the letters in Spanish that's not in English, has a little tilde on top. Good, and we actually have someone knowing the word tilde. Very few people know that, but we're going to be using it, so it's very important. Okay, the way you read it in statistics is we say X has the distribution that is uniform, U for uniform, because U is the first letter of uniform. By the way, next week, we're going to talk about the normal distribution. Any guess on what letter we're going to use? If we have a normal distribution, we're going to have an X tilde what? Won't be U. It's not a trick question, by the way. But it might help you remember why the U. Yeah, N, because N is the first letter of normal. U is the first letter of uniform. So it's kind of standard. Mathematicians are boring. We don't try and trick you or anything. We just use the most logical thing to use. U for uniform. And then A, B, because uniform, you have talked about the low and the high. Any questions on that? Okay, let's look at an example. So here's an example. Suppose that the time that students spend with a math tutor is uniformly distributed between 10 and 120 minutes. So you write X tilde U, 10, 120. Any questions on writing down the distribution, which you need to know how to do? You need to write the distribution, and that's how you write the distribution. So on the exam, I could actually ask you, write the distribution, and that's what I'm expecting. Okay, and if it was a normal, it would be an N instead of a U. Okay, then the question here is if a randomly selected student who used a math tutor is observed, find the probability the student will spend between 30 and 70 minutes with the tutor. Any questions on the question? All right, so the first thing you want to do is draw a picture. So here is the picture. We know that it's uniformly distributed. Let me like that so we can get on the same page. We know that it's uniformly distributed between 10 and 120. So on the x-axis, I'm going to put 10 and 120. We know that we have a rectangle because when you have a uniform distribution, the shape is a rectangle. I'm going to use the letter H for height. What is the area of the whole rectangle? The hint is it's easy. What's the area of the whole rectangle? I don't hear you put it in. It's 1. When you have a uniform distribution, there's a 100% chance that a randomly selected student will be at least as big as the smallest number you can possibly be, and no more than the biggest number you can possibly be. You see how that works? So the area of the whole rectangle will be 1. How do you find the area of a rectangle? What's the formula for the area of a rectangle? What's the formula? Who remembers it? Something you learned in probably elementary school. What's the area of a rectangle? Yeah, so length times width. I'm going to tend to use base times height. And the reason why I use those letters, length times width is fine, by the way, is L looks too much like a 1. So I use B and H because those don't look like numbers at all. So I tend to use base times height. It means the same thing. So I can write area equals BH, base times height, and that equals to 1. Any questions on that? How do I find the base of this rectangle? How do I find the base? It's not hard. Yeah, 110, but let me do the work. What you do is you take the right minus the left, and that'll give you how far it is from the left to the right. So we're going to take 120 minus 10. Any questions on that? Because if you go from the 10-mile marker to the 120-mile marker, you've got 110 miles. Do you see that? Because 120 minus 10 is 110. Or in this case, if it's from the 10-minute mark to the 120-minute mark, then that's a length of 110 minutes. Times the height, which is h. That's what we want to find. Now 120 minus 10 is 110 times h. Okay, so if we know that 1 equals 110 times h, how do we find h? So very basic algebra. How do we find h? Yeah, we divide left and right by 110. So we know that h equals 1 over 110. And there's our height of the rectangle. Any questions so far? Okay, then we're asked for the probability that we're between 30 and 70, right? Or that student will be between 30 and 70 minutes. So we want the probability that 10 is less than x is less than 120. Sorry, that's probability that 30 is less than x is less than 70. And I like to draw this picture here where I shade in between 30 and 70. And I want the area of the shaded region because that's how probability works. Probability is the area of the shaded region. But the good news is we have rectangles and we know how to find the areas of rectangles. So it's base times height. The base will be 70 minus 30. If you go from 30 to 70, then that length is 70 minus 30. The height we found out earlier was 1 over 110. So our probability is 40 over 110. Any questions on that? Any questions? Okay, so the next question I have is, let's see if we can find the first quartile for the time students spend with a math tutor. Who remembers what it means to be the first quartile? Who remembers what the first quartile mean? That happened in chapter 2. Yeah, 25% of the spread of the data. So it means 25% is at or below that number. So you're running the 25%, but it means 25% is at or below that number, which is the first quartile. So what I can do is I can draw a picture. And I still have the 10 to 110, because that's what the uniform distribution was. Then 25% is the area, or 0.25 is the area. It's not the value of x, it's the area. So it's very important. You don't put 0.25 down here. X is what we don't know. So I'm just going to label that as x, or Q1 if you want to write it that way. And we want to find out how to calculate that. So the idea is we look at this rectangle that goes from 10 to x and has height h, which was 1 over 110, and has area 0.25, and you plug in the numbers. So the area is 0.25. Area is base times height. So 0.25 equals b times h. And then that base is x minus 10. It's the right minus the left. The height is 1 over 110. Are there any questions on getting this equation set up? All right, so now the algebra is a little harder. It's still beginning algebra, by the way. It's not even close to intermediate algebra, but you have more work to do. What's the first step for solving this equation for x? Any thoughts? What should you do? Little algebra. What's the first step for solving this equation? Any thoughts? I don't see y'all jumping in. Right, so we want to get x alone. And what is the first step to get x alone? Turns out there's going to be two main steps. What's the first step? Notice this is x minus 10 in parentheses times 1 over 110. Any thoughts? I don't see y'all jumping in. So if you remember, the way it works is you do order of operations backwards. So the first thing, order of operations is because is the parentheses. So you would do x minus 10. And the last thing is multiplied by 1 over 110. So we go backwards, which means we're going to start dealing with them times 1 over 110. And the way you deal with the times 1 over 110 is you multiply left and right by 110. When I multiply x minus 10 times 1 over, times 1 over 110 times 110, I just get x minus 10. The whole point is they cancel. And 0.25 times 110. Then to get x by itself, if we have an x minus 10, we add 10 to both sides. So we say x is equal to 0.25 times 110 plus 10. And you can use a calculator or whatever you want to do, and you get 37.5. Any questions on that? And that would be the first quartile would be 37.5. Any questions? Okay. So I'm not going to answer all these, but I'm going to answer a couple of them. What is the probability? Let's look at this one because this turns out to be a really easy one if you know what to do. What is the probability that a student spends exactly 25 minutes with a math tutor? What is that probability? And this turns out to be really important, this idea. All right, let's remind us again. Let's remember again. If you spend exactly 25 minutes with a math tutor, what's the lowest number of minutes you can spend? Right, 25 minutes. What's the highest number of minutes you can spend? Also 25. So in the picture, where this had 30 to 70, now we're going to have 25 to 25. What is the length of the base if it goes from 25 to 25? Yeah, 0. Base times height is 0, and the probability is 0. So one of the things when you have a continuous distribution, the probability of being exactly a certain amount or a given amount is just always 0. Kind of cool? Any questions on that idea? Okay, let me go and give you a really important formula, and let's do at least one of them. If it's uniform between 10 and 120, how do we find the mean? What's your thought? How do we find the average or the mean? Because it's not that hard. If it's uniform between 10 and 120, what would the average number of minutes be? So that you have a 50% probability of being bigger than you or smaller than you. 50% bigger, 50% smaller. Where are you? See y'all jumping in. Okay, so there is no peak of this curve. The curve is flat, doesn't have a peak. Do you see that? For a normal distribution, there's a peak, but not for uniform. Uniform's flat. There's no peak. Just goes across. But if you want a 50% chance of being smaller and a 50% chance of being bigger, where are you? Yeah, jumping in. Not a trick question. It should be pretty easy. Okay, let me tell you, you're right in the middle. Yeah, you're in the middle. How do you find the middle of two numbers? Do you remember? How do you find the middle? Yeah, add them up and divide by, not n, divide by 2. It's just two numbers. You see? I mean, I guess technically it's n, but 2 is what you got. So you would just take 10 plus 120 over 2. Any questions on that? Which happens to be 65, but any questions? Okay, so whenever you have a uniform distribution, then the mean is just you take the low, add the high, divide by 2. Okay, and in letters that'd be a plus b over 2. All right, how about the standard deviation? Any guess on what you have to do for that? You want to do it by hand? Okay, you're not going to guess, by the way. Here's what you have to do if you want to do it by hand. You better take a calculus class. So it turns out the standard deviation is brutal to come up with the formula. So what you're going to have to do is trust me. I do teach calculus, by the way. And here's a big formula. If x is uniformly distributed between a and b, then the mean, remember mu, this letter is mu, the mean is equal to a plus b over 2. That we already talked about. Add them up, divide by 2. And the standard deviation, remember that was sigma, is the square root of b minus a quantity squared over 12. Okay, I do not expect you to have any clue on why the standard deviation formula works. The mean is pretty obvious. It's just the average of the two numbers. Standard deviation is nothing obvious about it. But if you happen to be a mathematician, then you can figure it out. But I'm not going there. Any questions on the mean and standard deviation? Okay, so here's an example. Suppose that the number of ounces of water that people drink from a drinking fountain is uniformly distributed between 1 and 8 ounces, and that the number of ounces of water that students use to fill their bottles in the drinking fountain is uniformly distributed between 4 and 16 ounces. So by the way, I fill my bottle. There's my water bottle. And that's how I get my water. I don't just use a quick drinking fountain because I'm in my office too long. So I'm a water bottle filler. And I tend to use this kind because it's better for the environment. Because then I can use it. I've used this like hundreds of times. Better than plastic. Okay, so let's suppose that you watch Thorn. Okay, by the way, Thorn was a student in my class. I like that name, so I use it. You watch Thorn take 2.5 ounce drink out of the drinking fountain. And Preston was a different student of mine, fill his water bottle with 5 ounces of water before he runs off to class. Whose water usage is more unusually small compared to the rest of the people who use the fountain for the corresponding water usage? Any questions on the question? Okay. How do we determine what have we learned in our class that helps you determine how unusual a value is? Who remembers? There's something that we've learned, chapter 2 actually, that tells you how unusual something is. It's a measurement of how unusual something is. Add and divide by n. There is no n here. There's really no them either. Outlier. How do you tell something's an outlier? We've learned that too. Very important for your project, by the way. It's the same thing. 2 standard deviations. So let me give you the way we talk about it, the z-score. Do you remember the z-score? Okay, so that's what happened. So what we need to do is we need to find the z-score for Thorne and the z-score for Preston. And who's got a z-score farther from 0? Does that make sense? So z, there was a formula we had in chapter 2, was x minus mu over sigma. That happened. And that was the formula. And the good news is we have a formula for mu and we have a formula for sigma when you have a uniform distribution. Mu is at a plus b over 2. Sigma is b minus a quantity squared over 12 and the square root of all that. Any questions? So then we do the calculation. Let's start with Thorne. So our mu now, so Thorne, notice, by the way, took a 2.5 ounce drink. Okay, just using the drink fountain, just like the, not by water bottle. Okay, and the amount people drink is uniformly distributed between 1 and 8. So what we need to do is we need to find mu and sigma when it goes between 1 and 8. So mu is going to be 1 plus 8 over 2. Which that one I can do in my head. 1 plus 8 is 9. 9 divided by 2 is 4.5. You're always welcome to have a calculator. And sigma is the square root of x minus mu. I'm sorry, sigma is the square root of b minus a squared over 12. So b was 8, a was 1. So we take the square root of 8 minus 1 quantity squared over 12. That one, don't even try doing that in your head. I can kind of, but I'm not even going to talk about it. Instead, put in a calculator, and you'll get about 2.02. Any questions on that idea? Okay, the z-score is x minus mu over sigma. Thorne's x value is 2.5 because it says Thorne took a 2.5 ounce drink. So we have 2.5 minus the mean, which was 4.5, divided by the standard deviation, which was 2.02. And when you calculate that, you get approximately -1. Any questions on that? So on the low side, but definitely not an outlier. We do the same thing with Preston. Preston's x was 5, because Preston took 5 ounces. The mean, so since it was from into a bottle, that was, if you remember, or if you read it, between 4 and 16 ounces. So we take 4 plus 16 and divide by 2. That's 20 over 2, which is 10. Sigma will be the square root of 16 minus 4 quantity squared over 12. And that, with a calculator, I got 3.46. And it's very important you know how to use a calculator. Okay? It's an online class, so, whatever calculator you want is fine. I made sure that I put the scientific calculator that Desmos made in every one of the calculators that come with the stats that we've been using. So that's one way. You click that and it'll give you a calculator. Okay. So then z is 5 minus 10 over 3.46. 5 because that's what x was. 10 because that's what the mean was. 3.46 because that's what the standard deviation was. And I got -1.45. Okay, who's more unusual, Thorne or Preston? Yeah, Preston's more unusual because Preston's z-score is farther from zero than Thorne's is. Do you see? So Preston's water usage is more unusually small. Neither are outliers, by the way. What do you need to make it an outlier? Do you remember? That was chapter 2 also. What do you need the z-score to be an outlier? Who remembers? Very important for your project. Yeah, either greater than 2 or less than -2. And that makes it an outlier. Okay, so it is 2:31, which means it's time for the secret word. And the secret word is uniform. Okay. By the way, when you hear the word uniform, you might think of the military. Why do they make military people wear a uniform? Not to be mean, by the way. That's not why they do it. Yeah, so they're all look the same. Okay, and a uniform distribution means that if you look at the graph on the top, the height is the same no matter where you look between A and B. So that's the reason why you call it a uniform distribution. You know, it's not some weird word. It's using the word uniform. Okay, so that is a secret word, is uniform. So that's about all I have to say, but I'm always happy to answer questions. I'm going to stop the recording and then stop my share. But let's do that.